Assalamualaikum and very good morning. We are from Group 3. Today we will present about our progress report, and our project title is Automated Solar Insect Killer in Paddy Field. Okay, we will proceed to introduction. Okay, as you all know, our project title is Automated Solar Insect Killer in Paddy Field. It can trap different types of insects that can affect the quality of crop yield production. This project is designed to apply a variety of electronic technology such as Arduino program and solar technology. Okay, we proceed to program statement. According to the Rice Knowledge Bank, farmers use an estimated average of 37% of their rice crop to first every year. Several common insects that attack paddy field are leafholder, wool maggot, grasshopper, armyworm, and many more insects that can cause highly visible damage to the system. However, the damage is highly enough to reduce crop yield production. In most cases, spray pesticide is applied during the early stage. However, by using the spray pesticide, it can cause harm to human and environment as well. So, as a solutions, our group plan to design system that can trap different species of insect using electricity, which is more safe and pollution free. To make our design different from any other design in the market, we input solar battery to the system. Okay, the operation of the solar battery during the daylight, the solar battery will store energy, and during night, the solar battery will discharge the energy to generate electricity. We also will install CCTV to the system to monitor our solar battery from various tree and thief. Our design have advantages. For long term, it help in energy saving. Okay, we will proceed to market survey.
Assalamualaikum, my name is Luqman. Let me continue this presentation with market survey analysis. Market survey is the process of collecting data to determine whether this product will satisfy the needs of our customer or not. So from their profession and age, we know that all the respondents can be considered have the knowledge on farming, since 40% of response are from related person, which consists of farmers and paddy planters, and the rest are public people which have the age from 20 to 60 years old. And we proceed to question number 3. From the chart number 3, majority of respondents have good rice, more than 50% of overall crop. And from chart 4 and 5, it shows that most respondents are using pesticides to overcome the pest problem in order to maintain their quality of rice. And from chart 6, majority of paddy planters spend a lot of money for the pesticide supply every year. And from chart number 7, most of farmers using the pesticide without considering the environment, since they are not well-trained pest users. And from chart 8, we know that around 80% of respondents are ready to change their pest control method into something that profitable to them or to the environment. And from chart number 9, we can say that this technology is not being exposed to Malaysian farmers yet, which we can consider it as a new technology that really useful to most of paddy planters in Malaysia. And from chart number 10, 76.5% of respondents are agree that we need to focus on effectivity of our system rather than minimizing of the cost of the system implementation. And from chart, based on chart 11, 60% of respondents have experienced crop damage caused by human. This shows that the possibility of our system being sabotaged by human, such as stolen or being damaged by irresponsible people, is high, so that we need to find the solution to overcome the problem. And from chart number 12 and 13, 60% of respondents agreed to install the CCTV as to monitor the plantations and also the pest killer systems. This means that they also concerned on the security of the system for long-term operation. The other 40% respondents didn't agree to add CCTV in the system, maybe because they want to reduce the price of the system installation, since the pest killer system is more prior than CCTV system. And from chart number 14, we can conclude that 82.3% of them choose the price between 200 to 600 for the system, which is the overall system. So we need to ensure that the additional security system is between that range of price. And for the last questions, to know that our respondent is interested to buy our product or not. So for the chart, 64.7% of respondents are interested to buy the product, and 23.5% are maybe interested with it, and the rest are not agreed at all. And therefore, we can conclude that most of the respondents are interested to implement the system in their paddy field as an alternative to the consumption of pesticides. Okay, that's all from me.
Okay, my name is Mohammad Azri bin Helmi. My matric number is 182508. Okay, for this electronic system design project, I've been given task to work on the design, schematic circuit and the simulation. Alright, firstly I will talk about the design. Our automated solar insect killer is built with the solar panel on top. Is because to attract the sunlight as much as possible to the solar panel to get the strong input power. And then under the solar panel we implement the CCTV. The CCTV is used to monitor the paddy plantation and also to monitor the system itself from being stolen by others. Okay, down the CCTV below it we implement the insect killer machine. Below that is the circuit box with its case to prevent it from the rain and other things like dust. Alright, on top of the soil layer we put the battery with the wire connected to the circuit, CCTV, insect killer machine and the solar panel. Okay, next I will talk about the schematic circuit. We use Arduino Uno as the controller. So we can see here we implement the light depending resistance to act as the sensor for the light intensity. Then it's connected to the input pin number 0. And then the output we put it here for the insect killer and the CCTV in pin number 10 and 9 respectively. Okay, I also use the LCD display screen to show the status of the system, whether it is on or off. And then I will talk about the Arduino coding before we proceed to the simulation part. For Arduino coding, we start with the include liquid crystal. This is the declaration for the LCD part, and then we declare the pin on the LCD system in the Arduino. We can see the RS to going to port 12, EN to port 11. RS the register select, and the EN is the enable. We can see the port D4, D5, D6, D7 is going to the input pin 5, 4, 3 and 2 in the Arduino Uno. Alright, then we proceed to the coding part in the main program. Start with the void setup. This is to make the program run continuously. Alright, serial begin and pin mode. We declare the pin of the output first. We choose pin number 10 for the insect killer and pin number 9 for the CCTV. Then we void loop is also this make the program run continuously. And the previous one is to make the program run when we press reset. There's the explanation for the previous part. Alright, the sensor value is the input from the light dependent resistor. I choose it to make into port number 0 in the input analog part, and then we make it into condition if the sensor value from the LDR is below than 5. It is make the insect killer and the CCTV on, which is in height 0 and 1. This is in one condition in port number 10 and 9 for the sensor value is less than 5, and then we print the status on the LCD print, and else is the condition in between with the first condition. In this condition, digital write is low for both insect killer and CCTV. It means it is off, and then it will stated in the LCD part the system will be off. Right now we go to the simulation part. Alright, here I run it. Okay, we can see here the system is off when there is light. Here there is light, and then I will move away the light source from to the LDR, and then system will be turned on. We can see here the insect killer and the CCTV will turn on also. In this simulation, I replace the insect killer and CCTV with the LED component. Right here, we move the light source to the LDR again. The system is turned off. So that's how this thing works. Right, thank you.